For atomic structure, you'll need to read pages 119 to 127 and answer 1 through 6, 9, and 10 on page 127. So the objective of this section is to understand what an atom is made of. And this is a very important section for the rest of this quarter and into third quarter. We have to understand what an atom is made of and what the periodic table tells us about atomic structure. So first of all, protons. Protons are positively charged particles that are found in the nucleus of an atom. Another particle found in the nucleus is a neutron. A neutron is a particle with no charge, and it's found in the nucleus. It's almost the same size and same mass as a proton. Electrons are negatively charged particles that move outside the nucleus, and we'll deal more with electrons in the next section. Okay, the mass of an electron is much smaller than protons and neutrons, and of course, like we said, an electron has a negative charge. The atomic number, which we'll show you here in just a second, is found on the periodic table, and that's the number of protons in an element, and it's unique to that element. And since atoms have a neutral charge, the number of electrons is the same as the number of protons. And so the atomic number, most periodic tables will give you some sort of a key. Okay, this one does. The atomic number is this number right here. And so if we look here, the atomic number of hydrogen is 1. The atomic number of lithium is 3. The atomic number of beryllium is 4. If we go across it this way, helium is 2 over here. So this number here, this atomic number, is the number of protons in a particular atom of that element. So hydrogen has 1 proton. Since we're going to start off talking about atoms being neutral, it's also the number of electrons. So hydrogen has, since its atomic number is 1, it has 1 proton and 1 electron. We'll get into neutrons here in just a second. So let me move this up a little bit. The mass number is the total number of subatomic particles in the nucleus. Okay, it's the number of protons and neutrons. And that's represented by atomic mass units. So the number of protons is always the same for a particular atom. So hydrogen, we just said, has an atomic number of 1, meaning it has 1 proton always. If we give it another proton, it's no longer hydrogen, it's something different. But the number of neutrons can change, okay? Atoms of the same element with different numbers of neutrons are called isotopes. And so if you look again on the periodic table, what they give you here is the average atomic mass. So we look at hydrogen. Hydrogen's average atomic mass is 1.00794. In other words, most hydrogen atoms are hydrogen with an atomic mass of 1. Okay? And so since that's the total number of protons and neutrons, that means that most hydrogen just has 1 proton. If you look at lithium, lithium has an atomic mass of 6.941. So that 6.941 is closer to 7. So if the atomic mass is 7, and we know we've got 3 protons, 7 minus 3 is 4. So most lithium has 4 protons. Now there is some isotopes of lithium that will have just 3 neutrons. Okay, beryllium, same thing. Beryllium has an atomic number of 4, so it has 4 protons. It has an average atomic mass of 9.012182. So that's closest to 9. So that means that if we have 4 protons, 9 minus 4 is 5 neutrons. So most beryllium has 5 neutrons. So normally what we do, the way we would write an isotope of some substance would be like this. We would say, if we're talking about hydrogen, we would say hydrogen-1. So we're dealing with hydrogen with an atomic mass of 1. We could also have hydrogen-2. That's hydrogen with an atomic mass of 2, which is another isotope of hydrogen. Or carbon-12. Sometimes you'll see it written out as carbon-12, meaning carbon with an atomic mass of 12. So the number of neutrons is equal to the mass number minus the atomic number. That's important. Okay, you'll have to do that a lot in here. So you might want to put a star outside of it. So the number of neutrons is equal to the mass number minus the atomic number. We're going to mention a couple of things here real quick that we may come back to later on. but if you go on to take chemistry, you'll definitely deal with this. First of all, Avogadro's number. That's the number 6.022 times 10 to the 23rd particles, which is 1 mole. That's the number of atoms in a mole of a substance. So 1 mole of a substance is equal to the atomic mass of the substance in grams. So if we look at this here, I said down at the bottom, the molar mass of iron is 55.84. If we find iron on here, move it up a little bit. Iron has an average atomic mass of 55.8. It's 845 on this one, okay? But that would be the mass in grams of 1 mole of iron. The mass of 1 mole of cobalt would be 58.993. We would probably stop at that point. The atomic mass of manganese is 54.94. The atomic mass of chromium is 51.9. I would probably round that to 52 grams if we're using just 4 significant digits. So that's atomic structure. Make sure you read through those pages in the book and answer those questions and submit them to me on Canvas.